When you're new to rigging and you try and wrap your head around everything at once, it can be quite daunting. So let me try and break it down into smaller chunks for you. Now, each of the big concepts that I'm going to mention here is going to get its own dedicated lesson in a later chapter. However, in this lesson, I'd just like to talk about the main concepts of rigging and some of the terminology that you'll need to know. Now, first off, you might look at a rig that has lots of bones and be really confused. But really, in all of these bones, and in any rig in fact, there are only three main functions that any bone will have. There will be deformation bones, control bones, and mechanism bones. So the deformation bones are the ones that actually deform the mesh. They do all the bending and the twisting. Then you have the control bones. This should be obvious. These are the ones that the animator uses to control the rig. And the mechanism bones, now these are the helper bones that are needed to make the rig do what you want through drivers and constraints. Now, if you think about these bones as only having these functions, hopefully it will become less daunting. Deformation, control, and mechanism. So how do you build a rig and connect everything so it does what you want it to do? Well, there's also only three main things. There's parenting, there's constraints, and there's drivers and custom properties. And they kind of work in tandem with each other. So parenting, this should make sense to you already. All objects and or bones can have a parent. So when the parent moves, the child can follow along, but it can also move freely. Then we have constraints. Here's just a little example. We're going to copy the location from this bone to the other bone. And now it will always follow along, even though it's not parented. Now, some constraints will not allow you to move or rotate the bone when it is constrained. So that's where our parenting comes in. So if this is a control bone that you needed to animate, you would give it a parent, so it would follow along, and then add the constraint to the parent and not the control. And now it follows along, and you can move the control freely when needed. Now, this parenting concept with constraints is used quite a lot, which is why I've mentioned it here. I want to plant that seed early. And then we have drivers and custom properties. Now, I've mentioned these two together because they kind of work together as buddies. Now, drivers can be used for some complicated things. However, the most common use in rigging by far is to use a driver as a switch to turn on or off a constraint. Now, it's common to create a custom property and then connect it to this constraint and drive it as this switch. That's why they kind of work together. Now, as I said, you can do some really complicated things with drivers, but this switch concept is as far as we're going to be taking it in this course. Now for some other important concepts. You will need to understand space. Now, I'm not talking about the galaxy, I'm talking about world space, local space, pose space, and transform space. It sounds really confusing, but these are all just coordinate systems that have different reference points. You also may have learned a little bit about different spaces before in some of the other courses, but armatures have extra spaces. But don't worry, as I said, this sounds more complicated than it is, and there'll be more on this later. Now, one big concept is weight painting. Now, this can also be called weighting, skinning, or binding. There's many different names, but basically this is how the geometry is moved by the rig. You assign weights to the vertices, and then those will follow along with the bones. Now, weight painting is a little bit of an art in itself. We'll be going over this in its dedicated lesson later on. Now, there's a few more seeds that I want to plant early, and that is that the order of the constraint stack and the modifier stack matters. It is calculated from the top to the bottom, so the order that you put your constraints or the order that you put your modifiers makes a difference. All right, is that seed being planted? Excellent. That's going to help you do some problem solving if you ever run into issues. Now, finally, this is probably the most important concept to understand. You are building a rig to be animated by an animator. Now, that might be you or it might be someone else. Either way, the rig should be as simple as needed and no simpler. Now, this doesn't mean it can't be super technical and complicated under the hood, and sometimes it has to be to get the desired result. But the aim is to at least make it really simple to control. And to me, simple means logical and neat. So it's good practice to organize your controls into layers so you can easily display the controls that you want and hide the ones that you don't, and give your controls custom shapes to make it easier to use, especially if you need to select a control that is obscured by the mesh. All right, so that is the rigging concepts in a nutshell. On with the learning. I'll see you in the next lesson. Naming things in your scene, especially your bones, is a super important habit to get into early on. So in this lesson, I'd like to take a little bit of time to talk about my naming convention and your naming convention. First, what is a naming convention? Well, it's a set of rules that you stick to when you're naming things. This makes things consistent, easier to remember, and hopefully logical. Now, your naming convention doesn't need to be the same as mine or anyone else's for that matter, although there are some inbuilt features in Blender that you can use to your advantage as a rigger, and there are already some common conventions out there. So if you have a smart naming convention, you can save yourself a bunch of time and mental energy. I'll do my best to explain what all that means, but I'll start by talking about some of my rules. Name everything. That means bones, objects, data, absolutely everything. Now, we're not going to worry about this rule for some of the demonstrations in this course, where we're just adding bones and whatever, just for demonstration purposes. However, if we're creating anything real, inverted commas, we are certainly going to name absolutely everything. Be consistent. Now, it's okay if your naming convention changes or evolves over time, but it should remain consistent within the same rig. In fact, in preparing this lesson, it has forced me to look back at some of my past work, and I've noticed a bunch of inconsistencies, so I'm now inspired to work harder at this. Make it easy to read. Now, I've purposely made that difficult to read to emphasize my point, because at the end of the day, you are going to be the one who has to find the names of the bones, and also the animator needs to be able to read and find the bones as well. So if you have a name that is easy to read, it's going to make everybody's life a lot easier. Now, you don't need to copy what someone else has done in their naming convention without thinking about it first. Now, there are some common conventions out there, then sure, that makes sense to use the same thing because everyone knows what we're talking about. But if it's a redundant naming convention that's come from other software, or it's someone else's bad habit, then I want you to really think about it before you decide whether that's something that you want to add to your naming conventions. I'll speak more about this later on. Be logical. Now, sometimes this might mean that you need to break one of your rules in order to keep it logical. And I think that is more important than trying to find the perfect naming system, which is going to work in every situation. Sometimes you just need to break a rule to make it logical. And don't do things more than once when you don't have to. If your character is symmetrical or has some symmetrical parts, Blender has some inbuilt features to be able to copy your work from one side to the other. We will take a look at that right now. When you're dealing with a part of the rig that is symmetrical, for example, the left arm and the right arm, Blender is smart enough to recognize the left and the right sides. As long as you use a specific naming convention, you need to tell it which side is left and right using either a suffix or a prefix, and you need to use a separator as well. Now, there's many valid examples, but let's take a look at some of them now. All right, so here's a bone. Let's give it a name. Bone name. Very creative, Wayne. Good work. So now we either need to give it a prefix or a suffix. Here's a list of some of the valid options. I'm only showing you the left, but obviously the opposite of that is right. So the first one is the lowercase l, then we've got an uppercase L. We've got the whole word left, and there's many different spellings for that. Doesn't matter what case that you use. And then we have 4 valid separators. That would be a decimal point or the dot, the period, a space, a hyphen, or an underscore. Let's just choose one of these valid examples. Bone name.l, this would be acceptable, or we could do left underscore bone name. Now, just as a reminder, this separator here doesn't need to be the same as any of the other ones. They can be different, they can be the same. It really doesn't matter. Blender is just going to look at the prefix with the separator at the start or the end of the name. Now let's have a look at a few bad examples. We've got left name, and this won't work because there is no separator. So Blender just sees this as one big chunk of letters. We've got name.left. That won't work for the same reason. In this example, name.l.more words. This won't work either because the L is in the middle of the name and Blender will get confused. Although there is one exception to this, and that is if you use name.l.001 or something like that. Blender is smart enough to figure this out because that's one of its internal naming conventions. When it duplicates a bone, it will append the 001 to the end. So if you've got those numbers on the end, it will, although that's not good practice in my opinion. So let's take a look at how you symmetrize or you mirror these things from one side across to the other. So here we are inside Blender, and I've just gone ahead and created a whole bunch of valid names that we'll be able to symmetrize across to the other side. These top 2 rows are using the underscore separator. You can see the names here, underscore left, underscore capital, all capitals. So these ones are using the underscore, and these bottom 2 rows are using the dot separator. You can see the dot separator there. So these are all valid examples. We either as a suffix or a prefix. If we actually wanted to symmetrize them over to the other side. Now, obviously the middle of our rig is this part here. I've just put a bone there called middle. So it was going to symmetrize across to the other side of that. And that is because that is where the origin point of our armature is. All right, back to edit mode. Now I'm going to select all of these bones here. Now by default, if you're using the left click select, you just right click and then you'll see the symmetrize option here. Although because I am right click select, I have to hit the W key to get that option up here. It's available in the armature menu here. You just see armature and then symmetrize. So I'm going to choose this option here and you'll see all of those names are valid. So it's just flip them across to the other side. So the underscore left has turned out to be underscore right, etc. So it's smart enough to figure out all of those different patterns and mirror them across. Now you saw in that example, those bones did not exist. So it will create them for you. And it will also set up any hierarchy or copy over any constraints. Although if the bone that you're trying to constrain it to doesn't exist, it's not going to work as expected. Now, at the time of this recording, the only thing that doesn't copy across when you do it this way is any drivers. You'll need to go ahead and manually create them. I've spoken to the developers about this, and after many years of nagging, they're actually, at the time of this recording, working on a solution. So yay! Now, just some more things to note. If the bones already do exist and we want to symmetrize them, so you'll see it there. If we do that again, I'm just going to symmetrize. It's going to move them into the symmetrical location of the bone that you have selected. So it doesn't have to create the bones for you. It can just reposition them. Although there's one more option that I want to show you, and that is the symmetry button up here, or the X-axis symmetry. If I select that and now I grab this bone, because these bones are already created, it's going to keep them in sync. So that is very handy. If you've already got some bones created and you need to make an update to one side, it's going to propagate over to the other side automatically. All right, so that is the symmetry with the left and the right sides. Let's take a look at my full naming convention, starting at the object level. So here is our beloved Melvin character. Now this character only has 2 objects in the rig, but other characters can have more. Now I'm using the word rig interchangeably to mean all the objects that are needed to move the character, as well as just the armature object. This is one of those words that has many different meanings depending on the context. Okay, so in this rig, we have 2 objects. We have Melvin underscore rig, which is also the armature object. So rig and armature mean the same thing. And we have Melvin underscore geo. Now geometry is also called mesh, but you notice the naming convention, I always have the character name first and then the label of what it is. So that way they remain alphabetical. But this is one of the inconsistencies that I was talking about earlier. So I have the capital letters for geo and only have the lowercase for rig. Now I did this for ease of readability, but now I'm thinking maybe I should be consistent and have everything in capital letters. Regardless, this is something that I am working on and hopefully you will work on too. Now it's also worth noting before we move on that this is the names of the container objects, and I also duplicate this name for the data. And if you get into this habit, it will make your life a lot easier when you need to append data from one file into another. Just trust me on that one. So this example only had 2 objects, but as I mentioned before, you could have many more. You could have a mesh cage or a mesh deformer to help you move. I would call that Melvin cage. If you had 1 lattice, you would just call it Melvin lattice. If you had more than 1 lattice, you would give it an extra label. You might say lattice head and lattice body. That's just to help clarify things there. Now, I always put the character name first, or the name of the object that I'm rigging first, so it remains alphabetical. Now, this really is my personal preference, but I use this same alphabetical approach to name the bones as well, which makes many rigging tasks a lot easier too. Now, before we get stuck into bone names and how I name them, let's take a look at the common pre-existing conventions. Now, it's common convention to name some bones with certain labels, like def, mech, control, IK, and FK. Now, you might come across some other abbreviations, but really that would be more personal preference rather than an industry standard in my opinion. So what do they mean? Now, def stands for deformation. These are the bones that actually deform your mesh. If you label them clearly, it's going to make your life easier. Now, MCH or mech is short for mechanism. Now, these bones are needed to make the rig function in a specific way. They're helper bones essentially. They don't move the geometry, but they actually help the bones do what you want them to do. Now, control, this should be pretty obvious. These are the controls that the animator will use, although in my opinion, this is a redundant label, which I will explain in a moment. And then we have IK and FK. These stand for inverse kinematics and forward kinematics. We will learn about IK and FK later. However, these labels would only be used when you have a limb that can switch between the 2 modes. It would be redundant to label everything with the FK label if that part or that body part didn't have an IK equivalent. Now, when you name a bone chain, what I like to do is give it a numerical number working from the start of the chain to the end. Let's just imagine this is an antenna. It's antenna 1, antenna 2, antenna 3, antenna 4. I want you to notice that I'm using a capital letter for the first A in this one. And that is the way that I signify that this is a control bone without having to put CTRL in the name. So where do I put the special labels? Well, let's imagine that these were deformation bones. Let's have a look at what I would call them then. I will put the label at the end. So all these bones still remain alphabetical. So all the antenna bones, or all the ones that are related to that antenna 1, stay alphabetical. All the ones that are related to antenna 2 stay alphabetical. And if this needed to be duplicated across to the other side, you will put the .L at the end. Now, the reason I use the snake case with the .L at the end is for ease of reading. The way we read is actually by recognizing the shape of the word first before the actual letters or the word. So I believe that the snake case is by far the easiest to read, and the dot separator at the end, that is the .L, quickly shows that this part is different to the rest. I mostly use all lowercase, but with capitals to emphasize certain parts, like the special labels or the .L. Makes it easier to read than the lowercase .L. Now, all the controls have a capital letter at the start, which helps for readability for the animators. And remember that these are the only bones that they should be touching. So I do not put the control in the name either at the start or the end, because that is redundant. It also means that the animator has to look partway through the word to actually see what the name of the bone is. Now, there's a few more things I do in specific cases. However, what I've mentioned here is the main concept, and there's enough information for you to grasp what I do in other situations, and either adapt it for your own situations or completely disregard it if you like to work in a different way. Now let's talk about some of my pet peeves. Now, it is really annoying when you're an animator if a bone chain is labeled incorrectly. So you have the start of the chain might be labeled with start and the end might be labeled with tip. Something like that. Just like keep them all numerical. That way, when they show up in the dope sheet or the graph editor, they are alphabetical and they're not out of order. It makes it really easy to animate. Another pet peeve is when a name is left as .001 at the end or .002. This to me just says that someone hasn't taken the time to label all their bones. Another thing is all caps. This just feels like it's shouting at me. I find it really difficult to read. As I mentioned before, the way that humans read is by recognizing the shape of the words. And if the shape is all capitals, it is really, really difficult. One more thing that I try to avoid or I dislike is when the numbers of a bone is concatenated with the name. Say, for example, finger 01, finger 02. I just find it easy to read when you have a separator. Now, I also dislike having the mech or the def as a prefix because, as I mentioned, it ruins the alphabeticalness, and I find it really difficult to read as well because you really have to look halfway up the word to actually find what the name of the bone is, rather than looking at the start of the word and you know what the name of the bone is. And finally, if something has the control prefix, I find this redundant. Now, having said all that, there is a reason why you might see the def, the mech, and the control listed as a prefix rather than a suffix like I do, and that is if you are using something like Rigify. And this is because it uses Python to search the start of the name, and then it can easily identify those bones and do a certain operation with them. However, if you're not doing anything fancy with Python like this, I think readability is more important. So that's why I opt to not put these labels at the start, because it makes it harder for the animators to read. All right, so that's a lot of information for this lesson. Hopefully it made sense, and hopefully it inspired you to start thinking about your own naming convention. Now, as I said, it doesn't need to be the same as mine, but hopefully you choose a logical one. As I mentioned earlier, armatures have a few more spaces than other objects in Blender, but all of these spaces are just coordinate systems that have different reference points. Now, I'll do my best to explain them all here, but the two main ones that you need to know are just world space and local space. If you don't quite follow along with everything else I explain, don't stress too much. It will most likely make sense to you later down the track. I found it really confusing when I was learning this, but then one day, all of a sudden, it just clicked. They're all just coordinate systems with different reference points. I've said that twice now for a reason. That's the thing that I want to sink in. They are just coordinate systems with different reference points. I wish someone had said that to me 3 times when I was learning. It would have helped. Okay, let's get started. Now, for simplicity, in these examples, I'm only going to be talking about the location because I think it's easy to understand, but it is applicable to rotations as well. Let's do this. World space, which is also called global space, is a coordinate system relative to the origin of the scene. Now, the origin of the scene is down here where these axes meet. So our monkey head here is 3 spaces to the right on the x-axis, so that is the positive x, and 3 spaces up on the z-axis, which is positive z. We have a world space of 3, 0, 3. Now, world space includes everything that puts it in this location. That is parenting, constraints, drivers, whatever puts it in that position gets included in world space. So just to reiterate this, over here, I have this silly little armature object, which is parented to this monkey head. It thinks it's at local space 3, 0, 0, but in world space, it is 1, 2, 3, 4, 5. It is 6 spaces to the right, and then 1, 2, 3 spaces up. So it has a world space of 6, 0, 3. I like to think about world space is where you see it in the world is what you get, or whizzy wiggy gig. Pretty sure I said that correctly. Local with parent. Now this space type is only available for bones or armatures. This is where the bone properties are actually evaluated relative to its rest position. That is where the bone started in edit mode. So here is my child. If I jump into edit mode, you can see it's in the same spot. Its local space is 0, 0, 0. If I move this 1 space to the right, which is positive x, we've got a local space of 1, 0, 0. Now I just have a marker bone here. This is just for visualization purposes. This is where it was in its rest position. So local with parent actually includes the changes made to a parent. So if I move our parent up, it's actually the changes here. So we've got 1 in the x, 1 in the local y. And that also includes any changes to any of the parenting along the chain. So if we move the grandparent along, it's the changes from here to here. And bear in mind, this local with parent also includes any transformations that may occur from constraints or drivers. So local with parent includes its own transformations, it includes the parent transformation, and it includes the transformations by constraints and drivers. It's basically the changes from its rest position to its current position. When dealing with objects, local space is always relative to the parent. And if the object doesn't happen to have a parent, you can think about it as being parented to the world. This monkey head doesn't have a parent, so its local space is relative to the world. It is 3 to the right and then 3 up. On the z-axis, this is its local space. Now, because it doesn't have a parent, it is the same as world space. However, our armature object over here is parented to this monkey head. So its local reference space is the monkey. So that is why it's 1, 2, 3 spaces in the positive x. Now, if we rotate this and we select, it still thinks it's 3 spaces to the left because it's relative to the orientation and the position of our monkey head here. Now, when you're dealing with bones, local space is relative to the parent. So here I have our child and here is the parent, but there's one key difference with bones, and that is the starting position is always offset to its own local edit mode. You can see it's in the same position in edit mode and pose mode. So that means rather than it being 1 in the positive x and then 1 in the positive y as a starting position, it's going to be offset and the starting position will be here. So this is 0, 0, 0. Now local space includes any transformations on the bone. So say if I move this to the right 1 space, that will affect its local space, that is a change, as well as any constraints or drivers that move the position or scale of our child bone here. But if we move the parent, let's say we move it up 1 space, that does not affect the local space of our child. So just in summary, local space includes its own transformations. It also includes any transformations from constraints and drivers, but it does not include any parent transformations. Pose space is another space that's only applicable to armatures, and that is where the bone properties are evaluated to the armature's object level. And that means the origin point of our armature here. Now, there's one thing to note before I go any further. If the armature happens to be at world space 0, 0, 0, then world space and pose space is going to be exactly the same. So that means our child bone here is at pose space 1 in the positive x and then 1 in the positive z, because that is the orientation of our object level. And it's also the same in world space. However, if we move the object container, let's just move it 1 space to the right, pose space for our child here is still 1 in the positive x and then 1 in the positive z, although world space is now 2 in the positive x and then 1 in the positive z. So it might be helpful to think about pose space as being object space, that is relative to the object container. And our final space is transform space, and this is only available for drivers. So let's just add a driver here, and you'll see down here we have transform space. So what is transform space? So basically transform space is only the actual transformations of these values here. It is going to ignore any parenting. So if our parent moves, it's going to ignore that. If there's any constraints or drivers that change the position or orientation of this child, it's going to ignore that as well. So basically, transform space are these raw input values here. Now, the final thing I want to talk about in this lesson is a local location setting, which is only available for bones. Now, what I'm talking about here is in the bone tab, down here, this local location setting. With this enabled, its local location has the y-axis pointing off in this direction because this is the way that I built the armature. And if I grab our y-axis here, it moves relative to its own local y-axis. Now this child bone is parented to this bone called parent, and the y-axis for that one is pointing straight up. So if I disable this one and then grab our y-axis, it's going to use the axis of the parent just for that location. So all the other things remain. So if we rotate on the X, it's going to rotate as expected. It's just going to change the location axes. Now you understand a little bit about space. I hope it no longer frightens you. As I said earlier, all you need to know for now is the local space and world space. And thankfully, those two are pretty easy to understand. In Blender and 3D in general, drivers are a way of having an input drive the output of something else. For example, we can make the rotation of this monkey drive the location of this cube. Now that's a really simple example. However, it is possible to do some really fancy things with drivers. Here I'm creating a bouncing ball based on a mathematical expression and the current frame number. So this function in here is taking a few inputs, it's taking the frame range and a few custom properties, and it's driving the output, which is the height of the ball. Now don't worry, we won't be doing anything as silly or as complicated as this in this course. We're going to keep it simple. And we're only going to scratch the surface of what drivers can do, because I don't want to overwhelm you too much by explaining a bunch of things that you're probably not going to need right now. In rigging, we often add a custom property to a bone and then use that to drive the influence of a constraint. And that's exactly what we're going to do in this lesson. Simple, yet powerful. Now, what is a custom property, I hear you ask? A custom property is a way of attaching your own data to anything inside Blender. Now, custom properties can be strings, that is text, or it could be many forms of numbers. It could be a Boolean, which is a true or false, which in Blender is just converted to a 0 or a 1. It could be an integer, which is a number that does not have a decimal point. It could be a float, which is a number that does have a decimal point, or it could also be a vector, which is an array of numbers. However, for this lesson, we're just going to focus on a float number that goes between 0 and 1. Now, all this sounds pretty fancy and complicated, but really it's not. Let me show you how easy it is. Let's get started. So let's learn about drivers and custom properties. All right, so I'm starting from a totally blank scene, and the first thing I'm going to do is add in an armature. So I'm going to choose my armature here, single bone, and let's turn on our bone name so you can see. And I'm just going to duplicate this one here, just with Shift D. I'm not worried about the position of these ones because this isn't a real example, it's just for demonstration purposes. So this bone here, I'm going to add a couple of constraints to and drive them. So this one's going to be our owner. This one is going to be the target number 1, target 0, 1, and this guy is going to be target 0, 2. Okay, so we jump into pose mode to add our constraints, and we're going to select our target first, shift select this one, and I'm going to choose a copy location, just like our other example that I think, hopefully I've put these videos in the right order, so you've already done this one before. Otherwise, bear with me, it'll make sense in a few videos time. So that one's jumped over there, and this is the constraint there. I'm going to leave it at world space, I'm going to leave all these the same. We'll mute it so we can actually see our bone in the middle again. And now I'm going to select the second target, and then this guy, and then Control Shift C, copy location. So now I have two constraints going on. So actually I'll unmute that one. And what I want to do is create a custom property that drives these values independently of each other. Well, not independently. I want one to go up and one to go down. Now in this example, there's going to be an error, and this is the design of my tutorial. But I want to show you the concept of how you get one property to control these two things. And then I'll show you how to fix the errors that I've made. All right, so I'm just going to mute these so we can see the bone in its default position. And we are going to add a custom property. As you learned from the intro, you can, it can be a string or a number. We're going to use the float numbers, and there's many places that you can add a custom property. We can add it on the object level. So if I click the object tab down here, we've got custom properties. We could add it on the data level. So down here we have custom properties, or we can add it on the bone level. And this is also, in the pose bone. So in pose mode, we can add it, or in edit mode, we can add it. Now, where do we want to add it? Well, we just think about it logically. We want this to be a property that can be animated by an animator, and that should happen in pose mode. So it should be in pose mode. And if this is going to be a bone that is going to be controlled by the animator, we actually want it on the bone level. So that makes logical sense to put it on the bone level in pose mode. Now that might be a little bit confusing, but 99% of the time, you do want to add your custom properties to the bone level in pose mode. There's just a few exceptions where you would add it elsewhere, but like me, most of the time on the bone level, pose mode. I've just clicked add there, and this has added a property. Now, if I click on the edit, you can see I can edit the settings here. So here we have a property name. We can give this a proper name. Let's normally you would give it a logical name, but for this example, I'm just going to call it my prop, just to show you how to change the property name there. Now the property value here is where we would change it. At the moment, the default is this is set to a float, which is a number with a decimal point. If we made this a number that didn't have a decimal point, it would become an integer. If you typed a string or anything in here like string, it would become a string property. Or if you typed true, it would become a Boolean, although that would be converted into a 0 or a 1, where true is 1 and false would be 0. But we are going to leave it at the default 1.0 for now, because that is the settings that we need for this particular tutorial. Now the default value, we can leave at 1, but this will be if we right click on the value and say return to default, this is what it's going to return to. So we can leave it on 1 if we want. So the minimum and the maximum, I do want it to be between 0 and 1, but I'll just quickly show you. If I raise this up to 10, now my property will go from 0 to 10, and the soft limits down here, this is going to say, hey, what value do you want the user to be able to slide to in the UI? So I can just say, well, I'm going to make this 1.0. So now my soft limit is between 0 and 1, but the actual maximum goes up to 10. Let me just show you what that means. So here we've got my property, and this will also show up in the item tab when we have our bone selected. So this is the same thing. You can see that is the same thing. But now, so with the soft limits, I can just drag with my mouse only up to that value of 1, what the soft limit was. But I can still type in here. I can type in, say, 5, because that is below our maximum, or I can go all the way up to 10. So that is what the soft limit does. So I'm just going to disable that and return it back to between a value of 0 and 1. Now with the is library overridable, if you're going to link this into a new scene, say for animation, and you're going to create a library override, then you would need to make sure that you enable this one so that the animator can actually edit it in that other scene. If you don't enable this one, when it gets linked in, this property won't be able to be changed. So hopefully that makes sense. I know I haven't spoken about library overrides in this course, but I have spoken about it in many of the other lessons. You can just think about this setting as if you are going to link the character in, make sure that you enable this on your properties. And the last thing that I haven't showed you is a tooltip down here. So you can actually just type in some helpful information. So some helpful information. And now when we hover over it, I'll just click OK. So when we hover over it, you'll see it pop up. Whoops. My property, some helpful information. So that's the tooltip there, which I think you will agree is not helpful information at all. And now I want this property to actually derive these values here, but I want one to go on and the other one to go off with this same property. Sounds tricky, but it's not. So I'm just going to split this vertically and turn one into my drivers editor. And what I want to do first is I want to show you the long way of setting up a driver, and then I want to show you the quick way, just so you have a better understanding of things. So if I wanted to add a driver to this property here, I would hover my mouse over it, right click and say add driver. You can see the shortcut is Control D. And then that will show up in my drivers window here. If I hit N, you can see we've got more information about our driver. And here it's actually just created a scripted expression. and the expression is going to be variable plus 1.0, which you will need to edit. And down here, this is the name of our variable, which is red, which means it's not actually working. So what this scripted expression will do, it will take this var and it will replace it here. So it'll take the var and then add 1 to it. So I'm actually going to delete that because I just wanted to take this one. And then we can change our settings down here. And I want it to be a single property. And then we need to choose the object. We only have one object called armature. And then we need to find the path to this property. Now, thankfully in Blender, we can right click and say copy data path, or the shortcut Shift Control C. And then we just hover over here and paste it with Control V. And that is going to paste that there. And then when we click update, you'll see that this purple value will change with when we change our my property here. Now let's just zoom in on our mapping here. So you can think about the drivers as the horizontal axis is the input and the vertical axis is the output. So if we're looking at here, this is our input and we go up, the input is here. And let's have a look at the output over here. So input is 1 and our output is 1. If we go to the halfway mark, you can see this line is moving and it's 0.61 and our value is 0.61. Now this line here doesn't need to be a straight line. We can actually edit it if we want. And then, you know, just change the mapping so that when our input, I'll grab this one as well. So when our input is 0.61, we go over here, our output is between 0.2 and 0.4, which is actually 0.284. So that's the way that we would change the mapping. Although for this example, we don't need to do any of that. So I'm going to undo, Control Z, Control Z, Control Z. And that would be how we set up a driver the long way. Now, I think you'll agree that that was pretty long. So what I'm going to do is just delete this driver. So I can actually delete it by selecting it here and then hitting delete or X, and that's gone. Or I could just right click in here and say delete driver. So all of that is gone. I've now disconnected it. Now I'm going to show you the fast way of doing it. So here's my property. I can right click here, and rather than copying the data path, I can copy as a new driver. And what that will do is Blender will be smart enough to do all those behind the scenes things and copy it into the buffer. And then I can hover over where I want to paste this and go right click and paste the driver. Ciao. And I think you'll agree, actually, let me select that. I think you'll agree that that was much faster than having to set up all of this stuff here. Okay, so that's working. Actually, let me just enable these ones. And now I want to copy this driver and put it down here, but then change the mapping so one turns on as the other turns off. It sounds complicated, but it's not. Now remember, I still have that that driver copied into the buffer, so I can just right click and paste the driver. But if you've done something else and it's no longer in your buffer or whatever, you can actually just hover over this driver and say copy driver. So now I've copied this exact same driver. I'm going to paste it here. Paste. So now I have two ones that are working exactly the same. So when I slide this one down, they're both going to go on, which is not what we want, but you can see the effect that that's having on our bone here. I actually want one to turn off. So I'm going to just pick one, just because of, for demonstration purposes. I want, when my input is at 0, I want the output of this one to be 1. So how do I do that? Well, I'm going to first select the correct one. So this is our first one up here. And then I'm going to go to the modifiers. And I can add a modifier and click generator. And this is just going to be a polynomial expression, or y equals mx plus c. All right, so I can actually change this. Actually, I'll just mute that other driver so you can only see the one that we're working with. When you add this generator, it's actually taken over those keyframes and they're no longer there. And we're just working with this value here. So I can actually change this value. And if you remember from mathematics, if we want to change the slope, we can change this to be a -1 and it will go in the opposite direction. So now it's going -1. But I need to move it up so that when my input is at 0, the value is at 1. So how do we do that? We just change this one here. We type in 1 to here. And now we've got the slope working the way that we want. So if we enable both of these, you'll see we've got the X. So now let's just slide this down and you can see over here on my purple, one goes on and one goes off. That's actually what I wanted. So that's how we connect the same property to two separate drivers and have them do opposite things. So pretty handy, I think you'll find. Now, one thing that you'll notice is when we go from our left position over to our right position, our bone is curving here. And if this is not what I want for this example, I just wanted it to go in a straight line. Now, why is it curving? And that is because in edit mode, it's partially going back towards its own default position. Now that I've shown you how I've done all this hard work, I'm actually going to correct it because it's not actually what I need for this situation. I want to get rid of this bend in the curve. And the way to do that is I actually don't need this driver on this position here. So I'm just going to right click and delete the driver and then raise it all the way up to 1. And that's because of the way that the constraint stack is going to operate. It's going to calculate from the bottom down. So if I have this one at 100%, it's always going to start here. And then when I slide from there, it's just going to go from this position to this position. It's not going to partially go back to its own starting position. So there we go. Hopefully you've learned a few things about how to create a custom property and the drivers editor. So the main thing I wanted to show you is how to connect this property or any custom property that we create to many different outputs and have them do different things. So hopefully you've learned something, but I'll see you in the next lesson. After you've done with creating all the mechanics for your rig, the next thing is to actually create custom bone shapes. Custom bone shapes will help keep things usable and clean and much faster for the animator. And when you combine this with color groups and grouping bones together in layers, it can really make things look neat and tidy. Here are some of the thoughts I have when I create some custom bone shapes. They shouldn't get in the way of the character because the animator needs to see what's going on in the screen without it being obscured, and it should be somewhat logical to the task it performs. However, if that shape becomes ugly or distracting, it's best to choose a clean and simple shape because animators will figure out what the control does, so you don't need to overcomplicate the shapes. For example, this foot roll here is kind of this half moon circle shape. So it rotates up in this direction. But over here, we've got a toe pivot, which also rotates in a similar way, but it does also go on all 3 axes. Now I've chosen deliberately to choose just a circle here rather than a sphere shape to keep things tidy. If it was a sphere shape, it would take up too much space and clog the view all the time. Now, a custom shape is just another object that's used to display in place of the bone. You can actually use most of the other objects in Blender to create a custom shape. There's just a few exceptions that you can't use. Now, if you want to use a curve as a custom shape, there's actually a few workarounds to get it to work because it doesn't work out of the box. You can create a bevel or add a modifier to it, and then it will show up. However, most people just use mesh objects, and this is what I would recommend too. Now let's talk about naming conventions. And as we've spoken about earlier, this is just the name that we give to our objects so that you can recognize what it is. Now there's many different naming conventions that you can choose. Here are some of the ones that I've seen here. They'll be short for widget or custom shape, bone shape, or gizmo. I'm sure there's others. I actually prefer the widget, spelled WDGT. That's my prefix that I like to add to my shapes, because to me, that looks like the abbreviation of widget. Whereas the WGT just looks like Wiget to me, and that really freaks me out. But you can call your widgets whatever you like. So how do we enable these custom bone shapes on your actual controls? But first here, I've got a really simple scene going on. I've got an armature with 3 bones. I've turned on the axes here, and these first 2 bones are aligned with the world, where the Z-axis is pointing up, Y-axis is pointing backwards, and the X-axis is pointing to the right. Whereas this bone here is in its default orientation, where the Y-axis is pointing up, Z is forward, and X is to the right. And it is also twice the size of these other bones. So these bones go 1 Blender unit in the world Y space, and this bone here goes 2 Blender units in the world Z space. And then I have a couple of arrows over here, which are just mesh objects. We have an arrow that is going 1 Blender unit in the Z axis. This one here goes 1 Blender unit in the Y axis. And this one goes 2 Blender units in the Y axis. How do we get these shapes to apply to our bones here? Well, that's really simple. We just jump into pose mode, select whatever bone that we want to add our shape to, jump over to our bone tab, and down here we have viewport display. And then under the custom shape, you can see our custom object here. So we can click in here and choose whatever object that we want. There we go. To clear it, we can just click this X. Another way of adding it is using the eyedropper, and we can choose it from the viewport or the outliner up here. So that is another way of adding it there. We can actually apply the same shape to multiple bones at once, but we can't actually use the eyedropper for this. But if we just click in here and hold down the Alt key, we can choose whatever shape that we want, and it will apply to all the bones that we have selected. So I'm going to choose the Y arrow small. Bang! And you'll notice that those ones are actually pointing in the right direction. So why are these two pointing in the correct direction and this one is pointing in the wrong direction? Just clear this shape so you can see the default bone. And now when we add a shape, the origin of our shape gets placed at the head of the bone, and then one blender unit in the Y direction will be the tail of the bone. So that is this direction. You can see here with this arrow, it doesn't go in the Y direction, it actually goes in the Z direction, which is why the arrow was pointing in the wrong direction. If we have a look at our good arrow over here, and then jump into edit mode, this vertex at the end is exactly one blender unit away from our origin here on the Y axis. So that means here will be the head of our bone, and this vertex will be the tail. And that is why these two shapes match up perfectly. Let's see if we can actually fix this one. We add our bad shape, and then try and fix our shape. So I'm going to select it, then jump into edit mode, and then I already have my cursor at the origin here. I'm going to rotate all the geometry, so R, X, whoops, I want to rotate around the 3D cursor, R, X, and then this way, -90, enter, and then you saw that that actually updated our shape here. So now I have fixed all my shapes. There's a few more settings to explain. So we actually have the scale option, so we can actually scale the shape up and down if we like. Now this setting, scale to bone length, is enabled by default, and this setting is why the shape is stretched along the whole length of the bone. If we disable it, it's not actually going to scale it along the bone length anymore. It's going to use the object scale. So that means it's only going to go one blender unit in the Y direction, which is only halfway up our bone, because the length is actually 2 blender units. So with this option disabled, you either need to scale this one bigger to match, or you can choose a shape that is already the correct scale. Here's one I prepared earlier. Ta-da! Now you might find all this scale a little bit confusing. So here is what I would suggest. Leave your scale at 1, always have this scale to bone length enabled, and then make your shapes 1 blender unit long in the Y direction. That way, you're always going to get perfect shapes. This option here, it says override transform. And this means we can display this shape here at another bone's location. This is very handy in many situations. So we can click in here and then say, we want this shape to display at bone number 1. Boom. So now if we move the location of this, it's always going to follow. And this is very handy in rigging, although there's one thing to point out, it's only displaying in this location. If we rotate and move this around, it's actually not changing the pivot point or anything of this bone. It's just changing the place where it's displayed. Now just to reiterate this, I'm going to bring up my rotation tool, and you can see that my pivot point is still over here. Now, if we rotate this one around, it is actually rotating, you can see up here, but the way it's visually displayed is being overridden by this bone here. Now, this might seem like a silly thing to do, but you can actually use it quite well. For example, here is a camera dolly rig, which ships with Blender. And if I move this camera control around, you'll notice that it always points towards the aim target here. And if I move the aim target around, it's always pointing at the camera. Now, how is this possible without creating a dependency cycle? Well, the answer is to override the transforms. So let's turn on all my layers here. So I've just got a hidden layer and this special bone here. This is just a mechanism bone, which happens to be parented to our aim control. So it's going to follow along wherever you move it. But this constraint is always going to copy the rotation of our camera here. So that means wherever you put it, it's always going to be pointing towards our target. And then if we have a look at the aim control here, and under viewport displays, you can see it's just using a custom shape, which is that aim widget. So the transforms are being overridden by that mechanism control. If I turn this off and then move it around, you notice that our aim control isn't rotating at all. It's just an optical illusion. And this would be an excellent use of the override transforms. Now the final setting is this wireframe option here. Let me just enable this custom shape, and you can see my bone is now a cube. So when we turn on the wireframe, it's going to ignore all the faces of your custom shape and just show the wireframe. I prefer to always have this enabled because the wireframe option is never going to occlude your mesh and get in the way. So that's pretty much it for custom bone shapes. But now you're probably thinking, geez, it's pretty difficult and a lot of work to create custom bone shapes. And you'd be correct. And that's why I use the Bone Widget add-on to help with all this. Now I'll include a link in the description. It was originally created by Christophe Sue for Blender 2.7. However, I have been doing my own development of this over the last year or so and made it work with Blender 2.8 Plus. I've also added some handy features that I wanted to see in the tool. Now it's free and it's open source and it's designed to help speed things up by keeping things organized, aligning all the shapes to match the bones. And it also has a bunch of time-saving tools, like the ability to mirror shapes from one side to the other, which is very handy. However, having said all this, it's important to note that CG Cookie does not give technical support on this add-on. This is something that I am developing in my spare time, and I've made freely available to all. So there are a few known bugs, which I'll sort out when I have time. But let me say this one more time. CG Cookie does not provide technical support for this add-on. This tool does work and it saves me a bunch of time. So maybe it can save you a bunch of time too.